Hey guys, my name's Helena, and today I'm going to go over a few topics in the lymphatic immune system lecture that's taught by Dr. Schechter for your Biosystems 2 class. So one thing I want to say is definitely pay attention to the objectives that he's provided when you're studying, because it's one of the most important topics that will come up on your exam. So this isn't everything, but it's just a few topics that I'm going to go over. So first I want to say that this lecture is about the lymph nodes and the lymphatic system. And one thing to know is that lymph is actually different than blood. They're not the same thing. So even though they're both fluids that are found in your body and they may seem similar, they're actually like two different things. They are both fluids and they have different components and appearances. For example, lymph is actually a clear fluid with that makes up lymph vessels, and inside the lymph vessels there's actually like water, proteins, electrolytes, and this is clear. But sometimes when there's lipids found in here, it actually gives like a white milky appearance to this fluid. So we also have our systemic blood vessels, and those provide nutrients such as carbon dioxide, oxygen, and other nutrients around our body. So only a few areas in our body actually have lymph vessels, and even though most areas of our body have the vascular system associated or are near it, providing all these nutrients. And just like we talked about for blood vessels before, lymph vessels are actually lined by endothelium, and the particular type is the simple squamous and endothelium. And the reason why it's called simple squamous endothelium instead of epithelium is because it's lining a vessel. So anytime it's lining a vessel, then it's going to be considered endothelium. And we also know that about 2 to 3 liters of fluid is produced per day of lymph. And this actually, like, you wonder where this goes, because if it doesn't go anywhere, then it just accumulate. And that's not how it works. Basically, it's actually filtered and then it rejoins the systemic blood flow. And so you can't keep making fluid, for example, in the cranial cavity, the CSF, because then it would just compress the brain. So similarly here, you see the same concept being applied with the lymph fluid. So as you move on to your other courses, there's like a term for this when there is an accumulation of lymph fluid, and this is called edema, which I'm sure most of you guys have heard about, or pitting. And this is when the body isn't able to filter the lymph fluid, and it leads to this condition. And it could be caused by different types of medications, or also like a medical condition, sometimes mostly related to the heart. So that's something to consider. Okay, so most lymph vessels are actually very highly permeable, and they're lined by simple squamous endothelium, like I mentioned, which is pictured here. So here's a picture of what a lymph vessel would look like. The dark green region which I drew are the endothelial cells, and the inside is where the lymph fluid is located. So right here, like I labeled lymph. And as you can see, there's pores against the outside wall, and these gaps show how permeable the lymph vessels are, but they're not always there. So this is the gap I'm talking about here and here. And this is also tissue fluid for here. So there are little anchoring elements from the surrounding connective tissue which regulate how permeable the vessel will be. And with that being said, we can conclude that most lymph vessels are leaky. So also note that the lymphatics, they contain valves that prevent reflux, and the lymphatic pressure is low. However, it's aided by contraction of the body's musculature system and breathing. That's why a lot of the times in normal people, there's no edema that occurs, because your body's muscles and your breathing is actually helping circulate the lymph fluid, and it's not staying in one area. So also note that although blood vessels contain red blood cells under normal conditions, they won't be found in lymph vessels. However, lymph does contain lymphocytes and other nucleated blood cells, but not red blood cells. So, where can you find lymph vessels and lymph? It's not found everywhere, but certain areas such as the CNS, bone marrow, tissues lacking blood cells, cartilage, epidermis, and the cornea are all places with no lymph vessels. So, other than that, most areas of the body contain it. So lymphocytes are actually very small and they have large nuclei embedded within them and little cytoplasm, and they get bunched together and they pick up a lot of stains. So here, don't mind my not so well drawn out picture of what basically lymph cells would look like over here. So you see the surrounding over here. So this is a topic that Dr. Schechter calls, it's basically the lymphoid follicle. And the lymphoid follicle has a pale staining germinal center and the periphery, which is much more densely stained. So as you can see here, this outside region, circular region, is much more densely stained versus the inside germinal center. And but this doesn't mean that there aren't lymphocytes in the center. It just means that they're more densely packed and stained around it. And then when you move out, there's another zone called the interfollicular follicular T zone. And the specific type of lymphocytes that are found here are T cells. So as we can see here, the three types of lymphocytes, the B lymphocyte, T lymphocytes, and NK cells, originate from hematopoietic stem cells, which can either become a myeloid stem cell or a lymphoid stem cell. And when the lymphoid stem cell, or actually the myeloid stem cell diverges, it can become red blood cells and then also various types of granulocytes, such as eosinophils, basophils, and also they can become platelets. But whenever this hematopoietic stem cell diverges and becomes a lymphoid stem cell, it can then become a lymphoblast, which actually becomes either a B lymphocyte, T lymphocyte, or a natural killer cell. So which is the main focus here. So those are the three main type of lymphocytes that we'll focus on. Lymphocytes are the immune surveillance, and they basically recognize self from non-self in our bodies. So when they encounter something foreign, it'll basically signal an immune reaction and alerts the body that there's a foreign substance in our that's going around. However, if it recognizes that particular molecule as a self, it won't set up an immune reaction. So T lymphocytes actually originate in the bone marrow, and they get away from the bone marrow during development into the thymus, and that's why it's actually called a T lymphocyte, because that's where it matures. And they mature in the thymus, and then after they're matured and they develop, they're actually ready to do their function. So when they leave the bone marrow, they aren't programmed yet and they're not mature enough and to do what they're destined to do. So they need to go to the thymus first. Then we have macrophages, and macrophages are things like phagocytes or antigen presenting cells, and this cell type takes up foreign molecules and degrades it and chews it up and then presents that degraded material basically on the cell surface, and it signals an immune system and alerts the body to take action when it's necessary. Then we have reticular cells, and that's basically the basic stromal cells that produce reticular fibers. And then dendritic cells are antigen presenting or processing as well, just like macrophages. And then lastly, we have our plasma cells, which are our B cells, and these are the cells that make immunoglobulins, also known as antibodies, and they're capable of antigen presentation as well. So now I'm going to go over the importance of lymph nodes. Just know that lymphatics are actually anatomically difficult to see in life, but they're actually very important because they serve physiological, immunological, and clinical importance. So physiologically, they're essential for capillary fluid balance function and digestive absorption of fat. Immunologically, they help produce, maintain, and distribute lymphocytes and antibodies and are the only structures to filter lymph. And clinically, they're significant factors in disease healing, physical examination, because they can be palpated in certain regions, and diagnosis, treatment, and prognosis. So lymph nodes are actually found all over your body and they're very tiny and not easy to find. Like I said, physicians can actually palpate certain glands where lymph nodes are found and they can be felt when they're inflamed. Um, once lymph nodes, only lymph nodes actually filter the lymph fluid, and areas include the cervical lymph nodes, which is usually palpated by physicians that I'm sure you guys would be familiar with. There are certain ones in your neck region, under your armpit, in your like on your armpit, and then like in the groin area. And basically, you want to think of lymph nodes basically as organs because multiple lymph vessels bring lymph to the node via afferent systems, and once the fluid is in the area, lymph gets filtered and basically a bunch of junk and dead cells and debris is like found there, and once it's filtered, multiple lymphatics drain at the hilum, which is the exit point through efferent system, and this is where multiple lymph vessels are basically coming out of the cell. So like I said, nodes also have their own blood supply with arteries and veins entering and leaving at the hilum. And the nodes are actually encapsulated organs. They have a connective tissue capsule enveloping them. And next we'll talk about different areas where they're found. So I wanted to go over a few areas where you would find lymph tissue or lymphocytes, and that includes the tonsils, the spleen, and the thymus. So the tonsils, the three main ones, the palatine, lingual, and the pharyngeal. These are the three major sites of tonsils, and they frequently get inflamed. And basically, when you get a sore throat and you get like when you get tonsillitis, it can either have a bacterial or viral origin. And this basically indicates that there's something going on in your immune system when it's inflamed. So it's a good way to indicate that, you know, something's wrong, like your immune system's down, and basically it causes inflammation of the tonsils. Another area with lymphatic tissue is the spleen. So the spleen is actually a unique organ that's polka dotted histologically. So it's really cool if you haven't taken a look at the picture that Dr. Schechter has provided on his slides. It actually looks like polka dotted. So it's found in the left upper quadrant of your body between the 9th and 11th rib cage on the left side. And the spleen is an encapsulated organ. And the capsule of the spleen is actually thin and delicate, so a variety of traumas and car accidents can cause it to rupture, and there's a lot of blood there. So splenic lacerations correlate with a lot of bleeding. An important concept that he talks about is this 1-3-5-7-9 rule, and it basically, the 1-3-5 are the measurements of the spleen, and 7 is the weight, so 7 ounces. And then the spleen actually, I don't know if it's 9 or 11, but whatever it is, the spleen is positioned between the 9th and the 11th rib cage. So that's why there's the 9 and 11 part. So the spleen has important functions, but it's not essential to life. So that's also an important concept. It does have like a lot of important functions, but it's not necessary to live. It makes a lot of antibodies, that's the lymphoid function of it, and throughout life, it can preserve some ability to serve in hematopoiesis, so that's blood cell formation, which is actually a very important function, but again, you don't need it to stay alive. There's the white pulp and the red pulp. The white pulp is the lymphatic tissue surrounding small arteries. And the the white pulp actually makes up 1/4 of the spleen, and then the red pulp makes up 3/4 of the spleen, and it's associated with veins and fibrous vascular network, and it contains some of the same cellular elements that we discussed, such as macrophages, reticular cells, and red blood cells. So definitely take a look at what it looks like, the polka dotted organ, which is the spleen, because of the white and red pulp. And just know that the white pulp is rich in lymphoid follicles by definition, and it contains the germinal center and lymphoid follicles, but the red pulp does not have that. So basically the lymphatic contribution of the spleen is associated with white pulp, okay? And then the thymus is actually located in the mediastinum behind the sternum, and the thymus is the organ to which precursors of T lymphocytes migrate to undergo their final development. So, like I mentioned earlier, T cells are different than B cells because they leave the bone marrow and they travel to the thymus, which is where they actually are matured, and then they can perform their function as T lymphocytes. So the thymus is actually organized into cortex and medulla, and the cortex is closely packed T lymphocytes, and there are different varieties of epithelial reticular cells and macrophages there. And the medulla is actually less packed lymphocytes, and the epithelial reticular cells and macrophages are also found there. So just take note of that. Okay, and that's the end of the video. If you guys have any questions, again, feel free to contact any of the biosystems tutors. Okay, thank you.